Hello everyone, this video is about statistics of image regions, image neighborhoods, and feature collection columns in Earth Engine. The codes are from the Earth Engine guides. For statistics of the pixel values, we have image.reduce region in Earth Engine. This all reduces the pixels as the statistic representation. The pixels can be of any geometry, or the pixels can be also of the single point. From the pixels or from that geometry or point, statistical computation are done. The first example here is of Sierra Nevada conifer forest. Sierra Nevada conifer forest is a vector file here, and it is a boundary here. So from the loaded imagery of Landsat 7, here we have the Landsat 7 5-year composite. This example here in particular computes the mean spectral values of that 5-year Landsat composite. When we run this, we get the result in the console as the dictionary, and we find the mean spectral values. The reducer applied here is ee.reducer.mean. We have the geometry as region.geometry, and the scale is 30 here. And we also have set the maximum pixels. And we will run this or check the results later. And there's also the second example here, and scale parameters is not specified here. Rather, we have specified CRS and CRS transform, and this works similar as the previous example. The other concept here is also about the consideration of pixel into that region. So there is unweighted reducers, pixels included if the centroid is in the region, and there is weighted reducers in which pixels included if 0.5% of the pixels is in the region. So two types of reducers, unweighted reducers and weighted reducers. And here is the maximum pixels. So this maximum pixels, if this is not set, it generates an error. So we either increase the scale or we set best effort parameters as true. So this is the first two examples. So we can also get the image statistics from the multiple region from the feature collection. So here again we have the imagery, and for this inputs we need to have image, and we need to have feature collection. So this is the feature collection here, and the previous one was the image. So you can see here we have image.reduce regions. In the previous example there was only reduced region. If we see here, it was reduced region, but here this is the example for regions. So we have reduced regions, so that is a difference. The output is the feature collection, and means are calculated in each feature geometry. And here we print the first feature. Statistics can also be applied by neighborhood. For this, we have image.reduce neighborhood. We provide the window size and windows shaped by ee.kernel. And the output is another image. And this particular example here uses the NAIP image, something called National Agriculture Imagery Program. And the image here has the example to quantify some differences between the logging activities. So here we have a reducer as ee.reducer.standard deviation, and this is something used to identify or check the difference between blocked area and the protected area. And we can add them as the layer. So we also have the statistics of feature collection columns. So this is done by FeatureCollection.reduce columns. We are calculating weighted mean, and here we are calculating the weighted mean, and weighted mean are not the regular means. They are different than the regular means. And you can see here we have selected the first property, and the weight selectors are the second property. So the weighted mean is calculated in this way. We have the next example here, the feature collection of US census block as census data as attributes. So this is the first feature collection, census as the feature collection. And we also have the total population and total housing units as our interest. So this is for the Benton County. And we have here, so you are getting the sum of these two different properties. Here we have dot not null to remove any empty values or any null values, and we want to have the sum calculated of these two properties differently. So we have dot repeat 2 times. If this is not included, it generates the error, and we can print the results. So if we run them all and check them once, so the first one was here about the ee.user.mean, and here we have different bands and their mean values. The second example was also the same. Only here we had specified the scale, but there was the other way to specify the scale by CRS and CRS transform. And then we had the third example. This was for the first feature of the feature collection. This was for the plot result, and we also had the fifth result here. So we had calculated the weighted mean, and result was 2.3. And finally, we also had the e.reducer.sum. So this had been done 2 times. And here we have some results. This is the sum for the first properties and the second property. So sum for 2 different property, and it had been repeated by 2 times. And for the image, that was the example for the, so this was the fourth example. So the original was the NAIP image. So a calculation of NDVI was done, and this was here we had used ee.reducer.standard deviation. So this was the SD of NDVI. So this was the very short guide adapted from the Optins and Guides. So I hope this was helpful. Thank you for watching.